In order to understand or in order to find the phase difference between 2 points in the same wave, you have to understand the motion of each particle or each point in wave. In order to see whether 2 points on a wave are in phase or out of phase, for that, you have to understand the motion of each particle in the wave. For example, in here, you can see sometime point A having downward direction, sometime it is having an upward direction. So you have to remember these 3 points. These are the key to understand all the concepts about waves. Okay. If 2 points in a wave are 360 degrees away or one wavelength away, they will be in phase. If 2 points have same direction from have same distance from mean position, they will be in phase. If 2 points in wave have same direction, they will be in phase. So these three conditions must be met. If one of them, if two of them are meet or met and one is not met, then we will say that the waves are not in phase. All these three must be fulfilled in order to see that the 2 points are in phase. If any of these three conditions are not met, we will say the waves are not in phase. For example, A and C. You can see that A is moving down and C is also moving down, and the distance between the two is 360 or one wavelength, right? 180, because 1D makes, if this is your D, it means this 1D makes 180 degrees difference, right? So 180, 180, 360. So 2 points A and C are 360 degrees apart. Condition one is satisfied. Condition one is satisfied, right? What about second condition? The second condition was two waves have same distance from mean position. So both are at same mean position. It means both have zero distance from mean position. Actually, they are at mean position. So their distance is same again. Condition two is fulfilled. Now, what about the third condition? 2 points in a wave must have same direction. Both are going down. It means A and C are in phase. Okay. Now, what about A and B? In A is moving down while B is moving up. So first condition, the third condition is not met. So we will say that the waves are not in phase. So we won't check the other two because the direction is not same. Okay. Although you can check it for your understanding that A and B are only 180 degrees apart, not 360 degrees. Okay. Right. And what about A and B? Again, you can see A is moving down, B is moving up, while they don't have the angle difference or phase or the difference of the wave between one wave. Okay, they are only few degrees apart, not 360 degrees apart. Okay. Similarly, A and B, they are in phase because A and B are 360 degrees apart. There is a one wavelength between the 2 points. Both have maximum amplitude and both have same direction. Okay, so this is just like for your understanding another concept, AC. So A and C are in phase because they have 180 degree or 360 degrees distance between the two. Both are at a maximum amplitude, like same amplitude, and both have same direction. But A and B are not because A is at positive maximum, B is at negative maximum. So they're not same. So this is like for your understanding and for your practice. You can take the screenshot and do the practice and see if you are getting the right answers or not. This is an exam question for your understanding that we are having a standing wave in here, and the standing wave is like this, going like this, and this, and from here it is reflected. So we will say that it's reflected, reflected, and reflected. Okay, and you need to remember for standing waves, the trough becomes crest upon reflection, and the trough becomes crest upon reflection. Okay, so here you can see that the crest was coming, but upon return it becomes trough. Okay. Now the question is, which of the following sections of the string would be in phase with each other? Now you can see that V and W, it's one section. We won't be considering the reflective part. We will only see the original wave part. Okay. So like that and like that. Okay. So we will consider only this part. Sorry, this part only. Okay. So V and W. So VW is one section and XY is another section. I have wrote the answer as C. Now, V and X are having a 360 degree between two. So it means first condition is satisfied, that they must be 360 degrees apart. Second, they will be traveling like in the same direction. So you can see that from here X is moving up and from here V is moving up, right? And the third point was they must have same distance from mean position. So both are at 0, 0. So it means all three conditions are satisfied. And similarly for W and X, W and Y, you can see. So therefore, if W is in phase with X and W is in phase with Y, so it means VW is in phase with XY. Therefore, the option is B. Now, what is the concept of phase shift or lead and lag? you can see that A is starting earlier, for example, at 0, while B is not starting at early, like A, it is starting at some different point, right, in time. And how much is the waves between 0 and B? You can see a quarter of a wave is between A and B. It means when you say I have one full wavelength, it means you are having a phase shift of 360. But if you say there is one quarter wave between A and B, it means a quarter shows only 90, right? So we will say that A is ahead of B by 90 because A is starting first and B is starting later. So A is ahead, right? Similarly in here, B is starting first, A is starting later. So we will say that B is ahead of A, or in other words, we will say A is lagging B by 90, or B is heading or leading A by 90. A is lagging, Lagging, lagging B by 90, or B is leading A by 90. Okay, I hope you understand the concept. This is called phase shift. And in here, one point is going up and the other one is going down. Of course, they are both in opposite direction, so they must have a phase difference of 180 or phase shift of 180. Now here, blue, orange color or black color, both are overlapped with each other. Therefore, we are just seeing one wave, so they will have no phase shift in here. Constructive interference and destructive interference. Now, if two waves are traveling in the same medium and they both have same frequency and wavelength, okay, then they will interfere with each other. Remember, if they don't, if two waves are traveling in the same medium, but they don't have same wavelength or frequency, they will never interfere with each other. Okay, they will just pass. So you can see that red and green, sorry, red and blue. So red and blue have same frequency and wavelength because their shape is same and their crest are meeting with each other, right? So if crest is meeting another crest, it means 2 and 2, you will get 4 in here, therefore bigger amplitude. But in here, you can see 2 is meeting with -2, so you get 0 amplitude in here, so you will get no wave in here. So when crest is meeting trough of another wave, then they will have destructive interference. And when crest of one wave is meeting crest of another, you will have constructive interference. What is path difference? For example, wave 1 is moving from some point to a point P, and wave 2 is also trying to reach point P, right? Right? But wave 1 is traveling 12 centimeter and wave 2 only traveling 8 centimeter to reach point P. So what is the additional path that wave 1 is covering? The wave 1 is covering some additional path of 4 centimeter, which is called path difference. And we denote that path difference as lambda x. So all you need to do just to subtract the bigger path from the shorter path and you will get the path difference. Okay. So what is the condition for constructive interference or destructive interference? One way to find out the constructive interference is just to only see the visual look of the waves. For example, wave 1 here is reaching crest, and wave 2's crest is also reaching in here. So crest is meeting crest at point P. It means definitely there is going to be a constructive interference, right? But this is not always true, or not necessary that you will always get a visual look of the wave. Sometimes you only have the data, like you have path difference, you have phase difference, you have wavelength, and you need to do some calculations, right? So for example, wave 1 is traveling 16 centimeters to reach point P, and wave 2 is traveling 8 centimeters to reach point B. What is the phase difference? What is the path difference between the two? The path difference between the two is simply subtract 16 from 8 and you will get 8 centimeters. Okay. Now I have written that the wavelength is 4 centimeter. And you can easily see that 8 is multiple of 2, right? Which multiple? The second multiple, right? So it means we see that if if path difference is multiple of wavelength, if path difference, which is 8, is multiple of wavelength, which is 4. So 8 is the multiple of 4, right? Then we will always have constructive interference. Remember, now 8 is full multiple, not half multiple. For example, 4's first multiple is 4 itself, and the second multiple of 4 is 8. But the half multiple of 4 is 6. So half multiple means destructive interference, but full multiple of wavelength means and constructive interference, right? So here you can see that the path difference is 8 centimeter and the wavelength is 4 centimeter, and 8 centimeter is the full integral multiple of 4, or wavelength. So we will say that whenever you have a condition where path difference is full integral multiple of wavelength, you will always have constructive interference. Or you can write the formula like that, where n is the integral multiple of wavelength, like first multiple or second multiple. So here 4 is second multiple, 8 is second multiple of wavelength, so therefore we will have the value of n as 2. Okay. Now for destructive interference, I have the same waves, but now wave 1 is traveling 16 and wave 2 is traveling 10. So they have a phase difference of path difference of 6, and the wavelength is absolutely same, like 4. Now you can see that 4 and 6, 4's first multiple is 4 and the next multiple is 8. This is full and 6 is half, right? So if the path difference is half integral multiple of wavelength, then we will say that they will always have destructive interference. Okay, so now here you can see 4 plus 6, 4 plus 2. So 2 is actually half multiple and 4 is actually full multiple. So this will be written as n plus half multiple of wavelength. That is called the condition for destructive interference. Okay, you can write, you can remember the conditions for constructive interference and destructive interference. Now you had two kind of graphs for phase difference, displacement versus distance and displacement versus time. And if you have a graph, for example, displacement versus distance, then how can you find the phase difference without any visual look, only having the data? So that is the formula that you need to remember. Path difference equals lambda over 2 pi times phase difference, okay? And for displacement time graph, that is the formula, which is lambda t over time period equals lambda phi over 2 pi, or lambda t over t equals lambda phi over 360. Now I will explain you in a while what does this formula mean, okay? For example, here you have a question and they are telling you two waves of wavelength 12 centimeter leave a source in phase. The waves travel along different paths to a point X. The path difference at X is 18 centimeter. Which of the following is the phase difference between the two waves at X? Now, first of all, you need to write the formula. Okay. So what was the formula? Lambda X equals lambda over delta X equals lambda over 2 pi into phase difference, right? Now, what is the path difference? The path difference that is given here is 18. The wavelength is given as 12. And that is 2, and this is delta phi, right? So 18 will go there. 2 pi over 12 equals lambda phi. And I'm going to say 6 2s are 6 3s are, and this 2 is cancel with this. So the answer is 3 pi. Now you can see that nowhere you can see the answer of 3 pi. So what should we do? Very good. But you need to remember that the condition for the points to be in phase was that 2 points must be 360 degrees apart. Okay, it means in 3 pi, those points which are 2 pi degrees apart are in phase, right? But you want to know the phase difference, not in phase. Therefore, you need to subtract 2 pi from here and you will get the answer as pi. So the first thing to remember, whenever you have such kind of answers, all you need to do just to subtract 2 pi if the question, if the answer is not given. If there would be an answer of 3 pi, you would not do any change. But if they have pi, it means they are trying to ask you that you should know the concept that every 2 pi means the point which are like 2 pi distance away, they have the same phase. So you need to subtract 2 pi from here and you will get the answer as pi. Now there is another kind of path difference question usually come in exam. You can see here the formula that you have to use is small t over capital T equals phase difference over 360. Now what is small t first of all? You can see that the two waves are not starting together from a same point, from a single point. So for that, you need to see that wave is moving up and wave is moving up. Okay, so you need to see at what point the both waves are having the same kind of behavior. For example, green is 0 at this point and purple is 0 at this point. At this point, green is moving up, and at this point, purple is moving up. And what is the time difference between the two then? 0.3 minus 0 equals 0.3. So that is your delta t. Okay. Similarly, if you take a closer look in here, if I talk about this point, which is 0.9, from here the is 1.9 are having that means time period 1.2 equals 1.2. So that is actually your time period. So capital is 0.3. Now what you need to find out the phase difference. So phase difference is lambda t over capital T equals phase difference over 360. So lambda t 0.3 times 360 over 1.2 equals delta phi, which makes it equals to 90, right? So it means that the phase difference between the two waves here is 90. So that is the end of waves understanding and concepts. I hope this lecture would be very helpful for you. Up till next video. Take care of yourself and it's goodbye.